Hi, as we have seen during class, the main problem preventing the wild use of CCS technology is its high cost. But what if we could extract some valuable product out of the process? This is where algae comes in. Thanks to algae, we can capture CO2 and produce a valuable product. First of all, let's see what we mean by algae.
Controlled algae production has been the subject of industrial experiments since the 1950s. Microalgae can be grown on purely inorganic nutrients, while converting carbon dioxide into carbon-rich lipids, greatly exceeding the capacity of the biofuel crops without competing for arable land. They free up oxygen and also produce valuable organic compounds, sought after by many sectors of the food, health and agricultural industries.
Now that we know what algae is, let's see how it's implemented in a process. We are gonna see two examples.
Over the last 6 years, scientists at Biofuel Systems have been developing a process to convert CO2 to energy by harnessing the natural power of photosynthetic algae. They've established a test facility next to a cement plant near the city of Alicante, from which carbon dioxide is captured and piped through 300 photobioreactors.
This is a feeding for the algae. This atom of carbon, they are going to put it in their structure.
A sophisticated circulation system ensures maximum exposure to sunlight, which along with the high level of CO2 enables the algae to reproduce 500 times faster than they would in nature.
This algae is going to be transformed into a biomass that is susceptible to be transformed in a biocombustible.
It looks like this is a long way from being a combustible. I mean, it looks like pond water, let's be honest.
We remove the water. This is the water that we obtain after removing the water. The water that we have into the... Yes.
No, you just fill
this
this up
water
out of the tap.
is so clean that we can reuse again and again in our process. This is our idea. We reuse. This is the biomass that we obtain.
Wow.
Okay?
This density of energy, I mean, it is here, but it's just not quite in the right form yet.
No, we need to transform it with our thermochemical process that if you want we can go.
They break down the molecular structure with heat and pressure, but the exact process remains top secret.
We can reach up to 250 bar, and we can reach up to 450 degrees. You can refine to obtain different fractions, kerosene, gasoline.
And what about the manufacturing processes? Of course, we know that oil is used in plastics, in other manufacturing.
Sure. The same chemical component that we have into the crude oil. So in the end, you can do whatever you want.
You can do whatever you could do with crude oil, you can do with this. So this is 100% algae-sourced crude oil. Whoa! It's not what we're used to seeing on Earthrise, is it? Wow, that's energy.
Yes, this is the meaning of density of energy.
The system acts as a depollutant. For each barrel, over 2 tons of CO2 is consumed, half of which will never return to the atmosphere.
We're located on the east side of the power plant with southern exposure to maximize the sunlight. We have installed a 5,000-gallon feed tank with 2 centrifugal pumps.
That main tank serves as the hub. That's where we add our CO2, that's where we add our nutrients, and that's where we return our water.
Algae comes out of the photobioreactors and it goes into the harvest tank. In a few hours, thanks to flocculation that helps the algae stick together, it settles to the bottom of the tank.
It's very dark green, the consistency of pesto. That material is what we would feed to an anaerobic digester.
The anaerobic digester can turn the algae into methane that the power plant could burn for fuel. Or, using gravity filtration, wet lipid extraction, and upgrading, you can make renewable diesel and jet fuel. Or by removing more moisture with a solar dryer and dry lipid extraction, you can make jet fuel or produce fish food and animal feed.
From a biofuels processing point of view, it makes sense. It is not extremely profitable, but when you look at what's happened, you've actually captured CO2 from a dilute stream and turned it into a value-added product.
If not making biodiesel out of algae or biomass, we can dump the biomass which has entrapped the atmospheric CO2 deep into the earth, thereby permanently eliminating the CO2 out of atmosphere. Besides this, some of the algae have huge amounts of oil and carbohydrates in them, so they can be used to produce quality animal feed. As we see, algae has huge potential in carbon capture technology.
If you give us the surface in the next 30 years, 1/4 of the desert of Libya, you give us that and we will make the production of 85 million barrels. That means we can reduce 20% the atmospheric CO2. It's not imagination, it's with the parameter you saw this morning in this plant.